Right now, as you listen to my voice, you're hurtling through the universe at over 1 million miles per hour. Earth is spinning. The sun is dragging us through the galaxy. And the galaxy itself is racing towards something we cannot see, something so massive that astronomers simply call it the Great Attractor. But here is what will keep you awake tonight. If you could somehow stop moving and look out into the void, you would see light from stars that died before Earth even existed. You would see galaxies so far away that their light has been traveling toward your eyes for 13 billion years. And between all of it, you would see the darkness. Not empty darkness, but darkness filled with invisible matter we cannot detect, energy we cannot explain, and perhaps civilizations we have never heard from. Deep space is not just far away. It is a place where time bends, where stars are born screaming into existence and die in explosions brighter than a trillion suns, where planets rain diamonds and black holes swallow light itself. Tonight, you are going to learn 101 facts about the most mysterious, terrifying, and beautiful frontier that exists. So settle in, close your eyes if you like, and let the universe reveal its secrets. Welcome back to Sleep Time Science, or if this is your first time here, welcome to the family. This is the place where curiosity meets calm, where you can drift off to sleep while your mind explores the wonders of the universe, the mysteries of nature, and the strangest corners of scientific discovery. Every week, we bring you long-form content designed to educate, fascinate, and relax. No loud sound effects, no jarring interruptions, just a gentle voice guiding you through topics that remind us how incredible it is to be alive in this universe. If you enjoy what you hear tonight, do me a small favor. Tap that subscribe button and turn on the notification bell so you never miss a new upload. Leave a like if this video helps you unwind, and drop a comment telling me your favorite space fact or what topic you would like us to explore next. Your engagement helps this channel grow, and it helps more people discover the joy of falling asleep to science. Now, let us begin our journey into the deep. Before we dive into our 101 facts, let us take a moment to understand what we mean when we say deep space. When you look up at the night sky, most of what you see with your naked eye belongs to our cosmic neighborhood. The moon is just over 1 light second away. The planets in our solar system range from a few light minutes to a few light hours distant. Even the most distant spacecraft humanity has ever launched, Voyager 1, is only about 22 light hours from Earth after traveling for nearly 50 years. But deep space begins where our solar system ends. It is the realm beyond the protective bubble of our sun's influence, a region called the heliopause. Out there, you enter interstellar space, the vast ocean of near emptiness between the stars. And beyond that, you find other solar systems, other stars, nebulae where new stars are being born, the remnants of dead stars, and eventually, if you travel far enough, the edges of our own galaxy. But even our galaxy, the Milky Way, is just one island in an incomprehensibly large cosmic ocean. There are at least 2 trillion galaxies in the observable universe, each containing hundreds of billions of stars. And between them lie voids so empty that if you were placed in the center of one, you might see no stars at all in any direction. Tonight, we are going to journey through all of it. We will start at the edge of our solar system, that familiar boundary where the known meets the unknown. From there, we will venture into interstellar space and learn about the stars themselves, those nuclear furnaces that create the very atoms in your body. We will visit alien worlds, exoplanets with conditions so strange they sound like science fiction. We will confront black holes, those cosmic monsters that warp space and time beyond recognition. We will zoom out to see galaxies colliding, cosmic webs stretching across billions of light years, and voids so large they should not exist according to our current understanding of physics. And finally, we will wrestle with the big questions. What is the universe made of? How will it end? And are we alone? 101 facts await you. Some will amaze you, some will unsettle you. And some, I hope, will fill you with the kind of wonder that makes the troubles of daily life feel very small indeed. Take a deep breath, relax your shoulders, and let the journey begin. Our journey into deep space begins at the doorstep of the unknown, the outer reaches of our own solar system. This is where the familiar ends and the infinite begins. Fact number 1. The edge of our solar system is not a clean boundary. There is no wall, no fence, no sign that says you are now leaving. Instead, there is a gradual transition zone where the sun's influence slowly fades into the background noise of interstellar space. This region is called the heliosphere, a vast bubble of charged particles that the sun continuously blows outward in all directions. Fact number 2. The solar wind, that stream of particles flowing from the sun, travels at speeds of up to 900 kilometers per second. It rushes past all the planets, past Pluto, past the distant dwarf planets, until it finally meets resistance from the interstellar medium, the thin gas and dust that fills the space between stars. Fact number 3. The point where the solar wind slows down dramatically is called the termination shock. Voyager 1 crossed this boundary in 2004, and Voyager 2 crossed it in 2007. At this point, the spacecraft were about 90 times farther from the Sun than Earth is. Fact number 4. Beyond the termination shock lies a region called the heliosheath. Think of it as a cosmic buffer zone, a turbulent area where the slowing solar wind piles up and mixes chaotically before finally giving way to interstellar space. Fact number 5. The outermost edge of the heliosphere is called the heliopause. This is the true boundary where the Sun's influence ends and interstellar space begins. Voyager 1 became the first human-made object to cross the heliopause in August of 2012, making it the first spacecraft to enter interstellar space. Fact number 6. When Voyager 1 crossed into interstellar space, it was about 122 astronomical units from the Sun. 1 astronomical unit is the distance from Earth to the Sun, about 93 million miles. So Voyager 1 was over 11 billion miles away, and yet it had barely scratched the surface of deep space. Fact number 7. Even at that incredible distance, Voyager 1 is still gravitationally bound to the Sun. It will take another 300 years before it reaches the inner edge of the Oort cloud, and approximately 30,000 years to pass through it entirely. Fact number 8. The Oort cloud is a theoretical shell of icy objects that surrounds our solar system. It is believed to extend from about 2,000 astronomical units to as far as 100,000 astronomical units from the Sun. To put that in perspective, the Oort cloud may reach nearly halfway to the nearest star. Fact number 9. We have never directly observed the Oort cloud because the objects within it are too small, too dark, and too far away. But we know it exists because of long-period comets, those ghostly visitors that occasionally plunge into the inner solar system on orbits that take thousands or even millions of years to complete. Fact number 10. Some scientists estimate that the Oort cloud may contain trillions of icy objects larger than 1 kilometer across. If true, it would contain more mass than all the asteroids in the asteroid belt combined, just scattered across an unimaginably vast volume of space. Fact number 11. Before you reach the Oort cloud, you must first pass through the Kuiper belt. This is a region of icy bodies that begins just beyond Neptune's orbit at about 30 astronomical units and extends to roughly 50 astronomical units from the Sun. Pluto is the most famous resident of the Kuiper belt. Fact number 12. The Kuiper belt is home to at least 4 officially recognized dwarf planets: Pluto, Eris, Makemake, and Haumea. But there may be hundreds more awaiting discovery, hidden in the darkness at the edge of our solar system. Fact number 13. Eris, discovered in 2005, is actually slightly more massive than Pluto. Its discovery was one of the main reasons the International Astronomical Union decided to reclassify Pluto as a dwarf planet in 2006. Fact number 14. There may be a massive undiscovered planet lurking in the outer solar system. Scientists call it Planet 9. Based on the strange orbits of certain distant objects, some astronomers believe a planet 5 to 10 times the mass of Earth could be orbiting far beyond the Kuiper belt, taking 10 to 20,000 years to complete a single orbit around the Sun. Fact number 15. The outer solar system is incredibly cold. At the distance of Pluto, surface temperatures drop to around minus 230 degrees Celsius. In the Oort cloud, temperatures hover just a few degrees above absolute zero, the coldest possible temperature in the universe. Fact number 16. Despite the extreme cold and darkness, these outer regions are not entirely dead. Some scientists speculate that certain Kuiper belt objects may have subsurface oceans kept liquid by radioactive decay in their cores. Life as we know it would struggle there, but life as we do not yet know it might find a way. Fact number 17. Light from the Sun takes about 5.5 hours to reach Pluto. By the time you reach the outer edge of the Oort cloud, sunlight would take over a year to arrive. From there, the Sun would appear as just another bright star in the sky, indistinguishable from thousands of others. And with that, we leave the gravitational embrace of our home star and venture into the true void between the stars. Stars, the engines of the universe, the space between stars is not truly empty, but it is close. Interstellar space contains roughly 1 atom per cubic centimeter. Compare that to the air you are breathing, which contains about 25 quintillion molecules in the same volume. The void between stars is a loneliness beyond human comprehension. And yet scattered across this emptiness like lighthouses in an infinite ocean, the stars burn. Fact number 18. The nearest star system to our Sun is Alpha Centauri, located about 4.24 light-years away. That means the light you see from Alpha Centauri tonight left that star over 4 years ago. You are always looking into the past when you look at the stars. Fact number 19. Alpha Centauri is not a single star, but a system of 3 stars. Alpha Centauri A and B orbit each other closely, while a smaller red dwarf called Proxima Centauri orbits farther out. Proxima Centauri is actually the closest individual star to our Sun. Fact number 20. In 2016, astronomers discovered a planet orbiting Proxima Centauri in the habitable zone, the region where liquid water could exist on a planet's surface. This world, called Proxima Centauri b, is roughly Earth-sized and represents one of the most exciting targets in the search for life beyond our solar system. Fact number 21. If you could travel at the speed of light, you would reach Proxima Centauri in just over 4 years. But with current technology, using the fastest spacecraft we have ever built, the journey would take over 70,000 years. Fact number 22. There are an estimated 200 to 400 billion stars in our Milky Way galaxy alone. That means there are more stars in our galaxy than there are grains of sand on all the beaches of Earth. And our galaxy is just one of trillions. Fact number 23. Stars are born in vast clouds of gas and dust called nebulae. These stellar nurseries can span hundreds of light years and contain enough material to form thousands of stars. The most famous example is the Orion Nebula, visible to the naked eye as a fuzzy patch in the sword of the constellation Orion. Fact number 24. The process of star formation begins when a region of a nebula becomes dense enough to collapse under its own gravity. As the material falls inward, it heats up. When the core temperature reaches about 10 million degrees Celsius, nuclear fusion ignites and a star is born. Fact number 25. Our Sun is classified as a yellow dwarf star, which is actually a somewhat misleading name. The Sun is white, not yellow, and it is larger than about 90% of all stars in the galaxy. Most stars are red dwarfs, smaller and cooler than the Sun. Fact number 26. Red dwarf stars are the most common type of star in the universe, making up about 70% of all stars. They burn their fuel so slowly that they can shine for trillions of years, far longer than the current age of the universe. Fact number 27. At the other extreme are blue giant stars, massive and hot, burning through their fuel at a furious rate. A blue giant might live only a few million years before exploding as a supernova, compared to the 10 billion year lifespan of a star like our Sun. Fact number 28. The largest known star is Stephenson 218, a red supergiant located about 20,000 light-years from Earth. If placed at the center of our solar system, its surface would extend beyond the orbit of Saturn. It is over 2,000 times larger than our Sun. Fact number 29. Neutron stars are the collapsed cores of massive stars that have exploded as supernovae. They pack more mass than our entire Sun into a sphere only about 20 kilometers across. A teaspoon of neutron star material would weigh about 6 billion tons on Earth. Fact number 30. Neutron stars spin incredibly fast. Some rotate hundreds of times per second, sending beams of radiation sweeping across space like cosmic lighthouses. We call these pulsars, and their regular pulses are so precise they rival atomic clocks in accuracy. Fact number 31. Magnetars are a special type of neutron star with magnetic fields about a quadrillion times stronger than Earth's magnetic field. A magnetar passing within 1,000 kilometers of Earth would erase every credit card on the planet and possibly disrupt the electrical activity in every living cell. Fact number 32. When the most massive stars die, they do not leave behind neutron stars. Instead, they collapse completely, forming black holes. We will explore these cosmic monsters in detail later, but for now, know that they represent the ultimate fate of the universe's largest stars. Fact number 33. Not all stars die in explosions. Smaller stars like our Sun will eventually swell into red giants, shed their outer layers as beautiful planetary nebulae, and leave behind dense cores called white dwarfs. Our Sun will become a white dwarf in about 5 billion years. Fact number 34. White dwarfs are incredibly dense, packing the mass of the Sun into an object roughly the size of Earth. They start out extremely hot and slowly cool over billions of years. The oldest white dwarfs in the universe have been cooling for nearly as long as the cosmos has existed. Fact number 35. In 2004, astronomers discovered a white dwarf about 50 light-years from Earth that had crystallized into a diamond. This cosmic gem is estimated to be 10 billion trillion carats, making it the largest diamond ever discovered. Fact number 36. Some stars do not travel alone or in pairs. There are systems with 3, 4, even 7 stars all orbiting each other in complex gravitational dances. Planets in such systems would experience multiple sunrises and sunsets, with skies lit by stars of different colors. Fact number 37. Not all stars remain attached to galaxies. Rogue stars, ejected by gravitational interactions, wander through intergalactic space completely alone. Billions of these stellar nomads may be drifting through the void between galaxies right now. Fact number 38. Every heavy element in your body, the calcium in your bones, the iron in your blood, the oxygen you breathe, was forged inside a star that exploded before our solar system formed. You are quite literally made of stardust. The stars are not just distant lights. They are the engines that built the universe, the forges that created the atoms of life. And among them, orbiting in the darkness, we have begun to discover worlds beyond imagination. For most of human history, we could only wonder whether planets existed around other stars. The night sky was full of lights, but we had no way of knowing if any of them harbored worlds like our own. That changed in 1995, when astronomers discovered the first exoplanet orbiting a sun-like star. Since then, we have found thousands more, and what we have learned has shattered our assumptions about what planets can be. Fact number 39. As of today, astronomers have confirmed the existence of over 5,000 exoplanets, with thousands more candidates awaiting verification. And this is just the beginning. Based on the data we have collected, scientists estimate that nearly every star in the galaxy has at least one planet. That means there could be more planets in the Milky Way than there are stars. Fact number 40. We cannot see most exoplanets directly. They are too small, too dim, and too close to the blinding glare of their parent stars. Instead, we detect them through indirect methods. The most successful technique is called the transit method, which watches for the tiny dip in a star's brightness when a planet passes in front of it. Fact number 41. The transit method has been incredibly productive. NASA's Kepler Space Telescope, launched in 2009, discovered over 2,700 confirmed exoplanets by staring at a single patch of sky and monitoring the brightness of over 150,000 stars simultaneously. Fact number 42. Another detection method is called the radial velocity technique. When a planet orbits a star, it does not simply go around the star. Both the planet and the star orbit their common center of mass. This causes the star to wobble slightly, and we can detect this wobble by measuring tiny shifts in the star's light. Fact number 43. The first exoplanet discovered around a sun-like star was 51 Pegasi b, a world that shocked astronomers. It was a gas giant roughly half the mass of Jupiter, but it orbited its star in just 4 days. This meant it was impossibly close to its star, closer than Mercury is to our sun. Scientists had never imagined such a world could exist. Fact number 44. Planets like 51 Pegasi b are now called hot Jupiters. They are gas giants that orbit so close to their stars that their atmospheres reach temperatures of over 1,000 degrees Celsius. Some are so hot that iron and glass vaporize in their skies and rain down on the night side. Fact number 45. One of the most extreme hot Jupiters is Kelt 9b, where dayside temperatures reach over 4,000 degrees Celsius. That is hotter than many stars. The planet's atmosphere is literally being stripped away by the intense radiation, leaving a comet-like tail of gas trailing behind it. Fact number 46. Not all exoplanets are giants. We have discovered thousands of rocky worlds, some of them remarkably similar in size to Earth. These small, rocky planets are the most exciting targets in the search for life because they could potentially have solid surfaces, liquid water, and atmospheres capable of supporting biology. Fact number 47. The TRAPPIST-1 system, located about 40 light-years from Earth, contains 7 Earth-sized rocky planets orbiting a small red dwarf star. 3 of these planets lie within the habitable zone, the region where temperatures could allow liquid water to exist. This single system has more potentially habitable worlds than our entire solar system. Fact number 48. The planets of TRAPPIST-1 are so close together that if you stood on the surface of one, the neighboring planets would appear larger in the sky than our moon appears from Earth. You could see their continents and clouds with the naked eye. Fact number 49. Some exoplanets exist in conditions so extreme they sound like science fiction. On HD 189733b, astronomers have detected winds blowing at over 8,000 kilometers per hour, more than 6 times the speed of sound. The planet's atmosphere contains vaporized silicates, which condense on the cooler night side and fall as rain made of glass blown sideways by those supersonic winds. Fact number 50. There is a planet called 55 Cancri e that may be largely composed of carbon. Under the immense pressures of its interior, much of that carbon could have crystallized into diamond. This world, roughly twice the size of Earth, could be worth more than the entire global economy many times over, if only we could reach it. Fact number 51. Some planets do not orbit any star at all. These are called rogue planets or free-floating planets. Ejected from their home systems by gravitational interactions, they wander through the darkness of interstellar space alone. Some estimates suggest there could be billions of rogue planets in our galaxy, possibly outnumbering the stars themselves. Fact number 52. Rogue planets are not necessarily frozen wastelands. If a rogue planet had a thick hydrogen atmosphere, it could trap enough internal heat to maintain liquid water on its surface or beneath an icy crust. Life, if it exists on such worlds, would never know the light of a sun. Fact number 53. We have discovered planets orbiting binary star systems, worlds with two suns in their sky, like the fictional planet Tatooine from Star Wars. The first confirmed circumbinary planet was Kepler-16b, discovered in 2011. Standing on such a world, you would cast two shadows and witness double sunsets. Fact number 54. Some exoplanets orbit stars so different from our sun that their years last only a few hours. Others have years lasting centuries. The diversity of orbital periods we have discovered reveals that planetary systems can take almost any configuration imaginable. Fact number 55. Proxima Centauri b, the planet orbiting our nearest stellar neighbor, is tidally locked to its star. This means one side permanently faces the star in eternal daylight while the other side experiences eternal night. The most habitable region might be the twilight zone, a narrow band between light and darkness where temperatures could be moderate. Fact number 56. The James Webb Space Telescope, launched in 2021, is now capable of analyzing the atmospheres of exoplanets in unprecedented detail. By studying the light that passes through a planet's atmosphere during a transit, we can identify the chemical signatures of gases like water vapor, carbon dioxide, and methane. Fact number 57. Detecting methane alongside oxygen in an exoplanet's atmosphere would be a potential biosignature, a possible sign of life. On Earth, methane is quickly destroyed by reactions with oxygen, so the presence of both gases together suggests something is actively replenishing them. On our planet, that something is life. Fact number 58. The sheer number of potentially habitable worlds in our galaxy is staggering. Conservative estimates suggest there could be at least 300 million Earth-like planets in the Milky Way alone. More optimistic calculations put the number in the billions. Somewhere out there, perhaps closer than we think, another world may harbor life. The universe, it seems, is filled with planets. Worlds of fire and ice, worlds of diamond and glass, worlds that could be like home. But there are places in the cosmos far stranger than any planet. Places where the very fabric of space and time is twisted beyond recognition. Of all the objects in the universe, none capture the imagination quite like black holes. They are places where gravity becomes so intense that nothing, not even light itself, can escape. They are cosmic abysses, points of no return, and yet they are also engines of creation, shaping galaxies and warping the universe in ways we are only beginning to understand. Fact number 59. A black hole forms when a massive star, at least 20 to 25 times the mass of our sun, exhausts its nuclear fuel and collapses under its own gravity. The core of the star compresses into a point of infinite density called a singularity, and the gravitational pull becomes so strong that space itself curves inward with no way out. Fact number 60. The boundary around a black hole, beyond which nothing can escape, is called the event horizon. It is not a physical surface, but rather a mathematical boundary in space. Cross it, and you are forever cut off from the rest of the universe. No signal, no light, no information can ever return. Fact number 61. If you were to fall into a black hole, you would experience something called spaghettification. The gravitational pull on your feet would be so much stronger than the pull on your head that your body would be stretched like a noodle, pulled apart atom by atom as you approached the singularity. Fact number 62. From your perspective, falling into a black hole, time would seem to pass normally. You would cross the event horizon without noticing anything special at that exact moment. But from the perspective of someone watching from a safe distance, you would appear to slow down, freeze at the event horizon, and fade away as your light stretched into invisibility. Fact number 63. This bizarre effect occurs because of time dilation, a consequence of Einstein's theory of general relativity. Near a massive object, time passes more slowly. At the event horizon of a black hole, time dilation becomes infinite. To an outside observer, anything falling in appears to take forever to cross the threshold. Fact number 64. There are different sizes of black holes. Stellar mass black holes, formed from collapsed stars, typically range from about 5 to several tens of solar masses. They are scattered throughout galaxies, often invisible unless they are actively consuming material from a companion star. Fact number 65. At the centers of most galaxies, including our own Milky Way, lurk supermassive black holes. These monsters contain millions to billions of times the mass of our Sun. How they formed and grew so large remains one of the great mysteries of astrophysics. Fact number 66. The supermassive black hole at the center of our galaxy is called Sagittarius A star. It has a mass of about 4 million suns and sits roughly 26,000 light-years from Earth. Despite its enormous mass, it is relatively quiet, only occasionally flaring as stray material falls into its grasp. Fact number 67. In 2019, the Event Horizon Telescope collaboration released the first ever image of a black hole. It showed the supermassive black hole at the center of the galaxy Messier 87, a monster containing 6.5 billion solar masses. The image revealed a glowing ring of superheated gas surrounding a dark central shadow, the event horizon itself. Fact number 68. In 2022, the same collaboration released an image of Sagittarius A star, our own galaxy's central black hole. Capturing this image was even more challenging because Sagittarius A star is smaller and more variable, with gas swirling around it in just minutes rather than days. Fact number 69. The Event Horizon Telescope is not a single telescope, but a global network of radio observatories working together. By combining data from telescopes around the world, astronomers created a virtual telescope the size of Earth, achieving the resolution needed to image objects as small as a black hole's shadow from thousands of light-years away. Fact number 70. When material falls toward a black hole, it does not go straight in. Instead, it spirals inward, forming a swirling disk of superheated gas called an accretion disk. Friction within the disk heats the material to millions of degrees, causing it to glow brilliantly across the electromagnetic spectrum. Fact number 71. Some black holes are surrounded by accretion disks so energetic that they outshine entire galaxies. These are called quasars, and they are among the brightest objects in the universe. A single quasar can emit more light than 1 trillion suns, visible from billions of light-years away. Fact number 72. The most distant quasar ever discovered existed when the universe was only about 670 million years old. Its light has been traveling toward us for over 13 billion years. By studying such ancient quasars, astronomers can learn about conditions in the early universe. Fact number 73. Black holes are not cosmic vacuum cleaners. They do not suck in everything around them. If our sun were suddenly replaced by a black hole of the same mass, Earth would continue orbiting just as it does now. We would freeze in the darkness, but we would not be pulled in. You only fall into a black hole if you cross within its gravitational influence. Fact number 74. Stephen Hawking proposed that black holes are not entirely black. Due to quantum effects near the event horizon, black holes should emit a faint glow of radiation, now called Hawking radiation. Over immense timescales, this radiation causes black holes to slowly lose mass and eventually evaporate completely. Fact number 75. The evaporation of a stellar mass black hole would take far longer than the current age of the universe. But given enough time, trillions upon trillions of years, every black hole in the cosmos will eventually fade away, leaving nothing but a faint mist of particles. Fact number 76. In 2015, scientists detected gravitational waves for the first time. These ripples in the fabric of spacetime were produced by two black holes spiraling into each other and merging about 1.3 billion light-years away. The collision released more energy in a fraction of a second than all the stars in the observable universe combined. Fact number 77. Gravitational wave astronomy has opened a new window on the universe. Since that first detection, we have observed dozens of black hole mergers, neutron-star collisions, and even hybrid events where a black hole devoured a neutron star. Each detection teaches us more about these extreme objects. Fact number 78. There may be a class of black holes we have never directly observed called intermediate mass black holes. These would have masses between stellar black holes and supermassive black holes, ranging from hundreds to hundreds of thousands of solar masses. Finding them would help explain how supermassive black holes grew so large. Fact number 79. Some theories suggest that tiny black holes, smaller than atoms, could have formed in the chaotic conditions of the early universe. These primordial black holes, if they exist, could be a component of the mysterious dark matter that pervades the cosmos. So far, we have found no evidence for them, but the search continues. Fact number 80. At the singularity inside a black hole, our current understanding of physics breaks down completely. General relativity predicts infinite density, but infinity is not a physical reality. It is a sign that our theories are incomplete. Understanding what truly happens at the heart of a black hole will require a new theory that unites gravity with quantum mechanics. Black holes are not just destroyers. They are sculptors of galaxies, sources of gravitational waves, and laboratories for the most extreme physics in the universe. They remind us that reality is far stranger than anything we could have invented. And now let us pull back even further and witness the grandest structures of all. We have traveled from the edge of our solar system, through the realm of stars, past alien worlds, and into the hearts of black holes. Now it is time to pull back further still and witness the universe at its grandest scale. Here, individual stars become meaningless. Even black holes are mere specks. At this scale, the building blocks of the cosmos are galaxies, vast islands of hundreds of billions of stars, bound together by gravity and separated by incomprehensible voids. Fact number 81. Our home galaxy, the Milky Way, is a barred spiral galaxy containing between 200 and 400 billion stars. It stretches approximately 100,000 light-years from edge to edge. If you could travel at the speed of light, it would take you 100,000 years just to cross from one side to the other. Fact number 82. The Milky Way is not sitting still. Our entire galaxy is rotating, with stars closer to the center completing their orbits faster than those farther out. Our solar system, located about 26,000 light-years from the galactic center, takes approximately 230 million years to complete one orbit. The last time we were in this position, dinosaurs had not yet appeared on Earth. Fact number 83. At the very center of the Milky Way lies a dense bulge of older stars, and at the heart of that bulge sits the supermassive black hole Sagittarius A star. This gravitational anchor holds the entire galaxy together, its immense mass influencing the orbits of millions of nearby stars. Fact number 84. The Milky Way is surrounded by a halo of ancient stars and globular clusters, spherical collections of hundreds of thousands of stars that orbit the galactic center. Some of these globular clusters are nearly as old as the universe itself, containing stars that formed over 13 billion years ago. Fact number 85. Our galaxy is not alone. The Milky Way is part of a collection of galaxies called the Local Group, which contains more than 80 known galaxies spread across roughly 10 million light-years of space. Most of these are small dwarf galaxies, but the Local Group also contains two other major spiral galaxies. Fact number 86. The largest galaxy in the Local Group is the Andromeda Galaxy, also known as Messier 31. It contains approximately 1 trillion stars, more than double the number in the Milky Way. On a clear dark night, you can see Andromeda with your naked eye as a faint smudge of light. When you look at it, you are seeing light that left that galaxy 2.5 million years ago. Fact number 87. Andromeda is heading toward us at approximately 110 kilometers per second. In about 4.5 billion years, the Milky Way and Andromeda will collide and merge into a single giant elliptical galaxy. Astronomers have already given this future galaxy a name, Milkdromeda. Fact number 88. When galaxies collide, individual stars almost never actually hit each other. The distances between stars are so vast that the galaxies will pass through each other like ghosts. However, the gravitational interactions will dramatically reshape both galaxies, flinging stars into new orbits, triggering bursts of star formation, and eventually merging the two supermassive black holes at their centers. Fact number 89. Galaxy collisions are not rare events. In fact, they are one of the primary ways galaxies grow and evolve. The Milky Way itself has consumed several smaller galaxies in the past and is currently in the process of devouring at least two dwarf galaxies, the Sagittarius Dwarf Elliptical Galaxy and the Canis Major Dwarf Galaxy. Fact number 90. Galaxies come in many shapes and sizes. Spiral galaxies like the Milky Way have distinct arms of stars, gas, and dust winding outward from a central bulge. Elliptical galaxies are smooth, featureless collections of older stars ranging from nearly spherical to elongated shapes. Irregular galaxies have no defined structure at all, often the result of gravitational interactions or collisions. Fact number 91. The largest known galaxies are giant ellipticals found at the centers of galaxy clusters. IC1101, located about 1 billion light-years from Earth, spans roughly 6 million light-years across, making it over 60 times wider than the Milky Way. It contains trillions of stars. Fact number 92. Galaxies are not distributed randomly throughout the universe. They are arranged in a vast cosmic web, with galaxies clustered along filaments of dark matter that stretch across hundreds of millions of light-years. Where filaments intersect, you find dense galaxy clusters containing thousands of galaxies. Between the filaments lie enormous voids, nearly empty regions of space. Fact number 93. The cosmic web is the largest known structure in the universe. It formed from tiny fluctuations in the density of matter in the early universe. Over billions of years, gravity amplified these fluctuations, pulling matter into the filaments and clusters we observe today. Fact number 94. One of the largest known structures in the cosmic web is the Hercules Corona Borealis Great Wall, a vast complex of galaxy clusters spanning approximately 10 billion light-years. It is so large that light would take 10 billion years to travel from one end to the other. Its existence challenges our understanding of how structures could have formed in the time available since the Big Bang. Fact number 95. Between the filaments of the cosmic web lie cosmic voids, regions of space almost entirely devoid of galaxies. The Boötes void, discovered in 1981, is approximately 330 million light-years in diameter. If our Milky Way were located at the center of the Boötes void, we would not have known other galaxies existed until the 1960s, when our telescopes finally became powerful enough to see them. Fact number 96. There is a region of space called the Great Attractor that is pulling our galaxy and millions of others toward it at approximately 600 kilometers per second. We cannot see it directly because it lies behind the dense plane of the Milky Way, but we can measure its gravitational influence. The Great Attractor appears to be a massive concentration of galaxies centered on the Norma cluster. Fact number 97. Beyond the Great Attractor lies an even larger concentration of mass called the Shapley supercluster, one of the most massive structures in the observable universe. Our entire region of space is slowly falling toward this enormous gravitational well. Fact number 98. The observable universe contains approximately 2 trillion galaxies. But the observable universe is just the portion of the cosmos from which light has had time to reach us since the Big Bang. The actual universe may be far larger, perhaps infinitely so. What lies beyond the observable horizon, we may never know. The universe is structured on scales that defy human intuition. Galaxies that seem like eternal fixtures in the sky are actually in constant motion, colliding, merging, and flowing along invisible rivers of gravity. And beneath all of this visible structure lies something even more mysterious. We have journeyed from the edge of our solar system to the largest structures in the cosmos. We have witnessed the birth and death of stars, explored alien worlds, peered into black holes, and seen galaxies collide across billions of years. But our exploration would be incomplete without confronting the deepest mysteries, the questions that keep astronomers awake at night and remind us how much we still do not understand. Fact number 99. Everything we have discussed so far, all the stars, planets, galaxies, gas, and dust, makes up only about 5% of the total content of the universe. The remaining 95% is composed of two mysterious substances we call dark matter and dark energy. We cannot see them, we cannot touch them, and we do not know what they are. Fact number 100. Dark matter makes up approximately 27% of the universe. We know it exists because we can observe its gravitational effects. Galaxies rotate faster than they should based on the visible matter alone. Galaxy clusters bend light more strongly than their visible mass can explain. Something invisible is providing extra gravity, and we call it dark matter. Fact number 101. Despite decades of searching, we have never directly detected a dark matter particle. It does not emit light, absorb light, or interact with normal matter except through gravity. Numerous experiments around the world are trying to catch dark matter particles as they pass through Earth, but so far, the mystery remains unsolved. Beyond our 101 facts, the mysteries continue to multiply. Dark energy makes up approximately 68% of the universe and is causing the expansion of space to accelerate. Discovered in 1998, dark energy remains perhaps the greatest puzzle in all of physics. We do not know what it is, where it comes from, or why it has the strength it does. The fate of the universe depends on dark energy. If it continues to accelerate the expansion forever, galaxies will drift apart, stars will burn out, and the universe will fade into a cold, dark emptiness called heat death. In the far, far future, even black holes will evaporate, leaving nothing but a thin soup of elementary particles spread across an infinite void. Some theories propose even stranger endings. If dark energy grows stronger over time, it could eventually tear apart galaxies, then stars, then planets, then atoms themselves in a catastrophic event called the Big Rip. Or perhaps the universe will collapse back in on itself in a big crunch. Or perhaps our universe is just one of countless universes in an infinite multiverse, each with different laws of physics, most of them hostile to life. And then there is the question that haunts us most. Are we alone? The universe is filled with planets. The chemistry of life is not rare. The ingredients for biology are scattered across every corner of the cosmos. And yet we have found no evidence of anyone else. No signals, no visitors, no megastructures built by ancient civilizations. This silence is called the Fermi Paradox, and it has no satisfying answer. Perhaps life is common, but intelligence is rare. Perhaps civilizations destroy themselves before they can reach out. Perhaps the universe is teeming with life, but the distances are simply too vast for contact. Perhaps we are looking in the wrong way or at the wrong time. Or perhaps, against all odds, we are the first minds to look up in wonder, the first consciousness to ask why, we do not know. And that is the most beautiful thing about deep space. It humbles us. It reminds us that for all our knowledge, we are still children standing at the edge of an infinite ocean, holding a candle against the dark. And so our journey comes to an end. We have traveled from the familiar edge of our solar system, past Voyager's lonely crossing into interstellar space, through the stellar nurseries where suns are born and the graveyards where they die. We have walked on impossible worlds, planets of diamond and glass and eternal twilight. We have fallen toward the event horizons of black holes, where time itself grinds to a halt. We have watched galaxies collide in slow-motion ballets lasting billions of years, and we have stood at the edge of human knowledge, staring into mysteries we may never solve. 101 facts, and yet they are only the beginning. Every answer we find reveals 10 new questions. Every discovery opens a door to deeper wonder. The universe does not owe us understanding. It does not care whether we comprehend it. But we reach out anyway, because that is what humans do. We are the universe trying to understand itself. Think about that for a moment. Every atom in your body was forged in the heart of a star that exploded billions of years ago. The iron in your blood, the calcium in your bones, the oxygen filling your lungs right now, all of it was cooked in nuclear fires and scattered across space long before Earth existed. You are not separate from the cosmos. You are made of it. You are the cosmos, looking back at itself, asking questions, seeking meaning. And perhaps that is the greatest fact of all. In a universe so vast that light takes billions of years to cross it, on a small rocky planet orbiting an ordinary star in an unremarkable corner of an average galaxy, something extraordinary happened. Matter became aware. Stardust learned to wonder. Tonight, as you drift towards sleep, carry that thought with you. You are rare, you are precious, you are a way for the universe to know itself. And out there in the deep space we have explored together, the stars are still burning, the galaxies are still turning, and the mysteries are still waiting. Thank you for spending this time with Sleep Time Science. If this journey moved you, helped you relax, or sparked your curiosity, please take a moment to subscribe and leave a like. Share this video with someone who needs a reminder of how incredible existence truly is. And let me know in the comments which fact amazed you the most, or what cosmic mystery you want to explore next. Until next time, sleep well, dream deep, and remember, you are made of stars. Good night.